In this video, we're going to look at topic 64, example 5, where we write an equation from a graph. So we're told a scenic train ride makes trips on an old mining line, so most likely that's kind of a there and back trip. The graph shows the distance y in kilometers of the train from the station. So we're talking about this being distance from the station and x minutes after the ride begins. So x is in terms of minutes. All right, it looks like we start obviously at 0 minutes, and it looks like the total trip will take 30 minutes. What equation represents the distance from the station as a function of time, and what is its domain? Okay, so let's kind of go through this problem. This is information, right? This isn't something that we know ahead of time. This is something they're telling us now. So they're telling us the graph shows a reflection of an absolute value graph across the x-axis. So absolute value graphs kind of look like a V, right? And this one would be that upside down V, so that's why it's a reflection. And a translation upward and to the right. So normally, right, our parent function would be right at the origin. This graph, the vertex, is shifting right and up. So that's kind of important to note. We are going to end up using that vertex in our equation. The general form of this absolute value function is y is equal to negative a times the absolute value of x minus h plus k. Now, this negative is in terms of the reflection. So sometimes you're going to see this function without a negative there. And that's just this kind of a more standard general form. But because we know this is a reflection, the book is already throwing that negative in there for us. And the next part of this is where h and k, so h and k are actually, h and k represents the vertex. So our vertex here is 15, 15, and those are the h and k values. And negative a indicates that the graph opens downward. So I kind of mentioned that already, where we're already stating that it's going to be that reflection that opens down. So how would we actually come up with some type of, they want us to find a function, right? What equation represents the distance from the station as a function of time? Well, if we're looking at this equation, y is equal to negative a, absolute value of x minus h plus k, well, we want to look at what parts of this we have. And what we're trying to do is to solve this, to come up with a function, we need an a value, an h value, and a k value. Well, right now, I know that I have an h and a k value because I know what the vertex is, 15, 15. So we're going to wind up using that. But I don't know what a is, so we're going to have to solve for a. And it's actually not going to be too bad. You'll see pretty quickly how you can solve for that. So I'm going to take this h and k value and plug in, because they talked about the vertex being hk. So I'm going to say negative a is x minus 15, or the absolute value of x minus 15 plus 15. Again, h and k being our 15 and 15. Now, I still need to figure out y, negative a, and x, and what I'm looking to solve for is a. So what I'm allowed to do is I can pick any point along my graph, and I can plug those values in for x and y, right? Because we're given x, y coordinates. Probably the easiest one is I have the point 0, 0. Let's change this color. Let's put it green. We have the point 0, 0. So what I can do is I can take that coordinate point of 0, 0 and plug it in as my x and y values. So I'd wind up with 0 is equal to negative a is less than 0 minus 15 plus 15. And now, let's keep highlighting. Now I have a variable, or an equation with only one variable, which means I should be able to solve for that variable. So let's simplify this with 0 equals negative a. 0 minus 15 will be negative 15. And I can just keep going until I wind up solving for a. So I'd have negative a times 15 So this would be negative 15a plus 15, right? We can subtract 15 from each side. Divide by negative 15, and that tells me that the a value is equal to 1. So we talked about the general form being y equals negative a, absolute value of x minus h plus k. To solve this, or I'm sorry, I keep saying solve. To represent an equation, we need an a, h, and a k value. Well, we know that h is 15, k is 15, and now we know that a is equal to 1. So the question, what equation represents the distance from the station as a function of time? This right here is my equation that represents the distance from the station as a function of time. The second question, what is its domain? Well, we can go back to our trip. Domain being our x values, we started here and the trip ends here. So my domain would be 0 to 30. And that represents the total time of my trip, right? We started at 0 minutes. We rode to it looks like we took the mining line to an old, I guess an old mine. They don't really state where it goes to. And then we turn around, we come back, and we get back to our original spot at 30 minutes later. So the entire trip would take 30 minutes, and that would be a good domain. But the idea is really when you're looking for something like this, when you're trying to come up with some kind of function, to do that, you're going to need to figure out the a, h, and k values. The h and k values are your vertex, so you'll always be able to find that if you have the graph. You'll find a vertex. And then to find a, you'll have to plug in x and y, pulling numbers from your graph. All right, pick any other coordinate. Now, I could have picked 0, 30, right? Like I could have picked this point on my graph. I could have picked this. This is probably about 2010. I wouldn't pick that because it's not specific enough. But any point along that graph, if I knew the exact coordinates, if I plugged those in as x and y, I would solve for a, and I would have gotten 1. So any coordinate on that graph would have been acceptable. And that's it. Good luck with it.